Alright, time for another draft science video presentation. Just making sure the recording's working. Anyway, so we have another comment by whatever this guy's name is. Anyway, but I don't know if it just distracts from the subject, but we'll try to deal with it and try to keep it, just focused on what I think the real point is what is argued about the two slit. And the two slit is argued as a verification of some wave concept of photon. And the point is all of the ways of describing it as a wave don't work. And the physics they accept in some respects are physics that doesn't fit the wave model. So they have an underlying physics that they use when they have to get the right answer, and then they have a physics they use to argue quantum mechanics and excuses for, like, say, Feynman. So let's say Feynman says something kind of simple. Okay, he makes an argument that whatever goes in to one of these slits gets randomized, and that's just the way the universe works. So every single photon that goes in gets randomized, every single one. Now you can sort of understand that you could just take that and use the single impediment instead of the open slit, right? And you could say, well, that model doesn't work because we clearly see a huge, gigantic brightness here in the center. So if this slit is large, many wavelengths of light in distance, this spot here will get very, very bright. It's not only twice as big, but it's like 90% of the light will be here, where that won't happen with the impediment. So if you have a decent sized impediment, same size as this opening, you won't get as bright a spot in the center. It'll still be bright, but it won't be nearly as bright as this one. And the fact is your bars will be a little bit blurred out because you're sending a bunch of light this way, okay, in this, near the center, but not the center, okay, so it's not concentrated in one place, and so it does create some blurriness in the pattern near the beginning, so it gets a little bit, the brightness is spread over a larger area, let's just say that. So just from the fact that the brightness is spread over a larger area, you could make the obvious deduction that some whole photons are going through and hitting here, and they're not creating the fringes. And so this is about the surfaces. So Feynman's theory says the surfaces are irrelevant. And what's really this is about is some sort of Heisenberg principle that because I have a slit of a certain size, I know too much about the photon's location, and therefore the photon has to, change its location. So I can't know where it's going. So it has to change where it's going. Some kind, the theory is just mush. So the way is what I'm just arguing. There's ways to deduce that out of being a realistic explanation. And there's ways of pointing out that if you really look at the experiment, you can see it's just about the surfaces. All right, so we'll get to his. So anyway, this is a nice enough comment. Just goes through how, well, they really should pay attention, and the forums are biased, and they should accept counter blah 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 blah. Then he gets to this part. Please, when you have had your vacation, see my comment and links in your "What is a photon sensible answer" video. So this was a comment I missed. Okay, and it has all these links. And this is where you just get into a bunch of obscuria, a bunch, the minutia. The minutia is not unimportant, but it is a lot of it before you get to the kernel that makes any difference. Like I said, the kernel of Feynman's theory is it doesn't matter where the photon goes. And I would say that you could just know it's not the right answer. Because if I make the slits very, very wide, it's clear that the photons just go right straight through the middle. And then it's not until I make the slit the surface more and more relevant, I have to give more photons a chance to hit it. The more chance they have to hit it, the more likely it is that I create a pattern. So that connection is just too logical to sit there say that, let's go with this extreme description instead of the one that seems pretty obvious, which is it's really just dependent on what percentage of your photons are going near the surface will tell you how many of them will be deflected into a fringe. So the fringes are entirely just the photons that went by the surface. And then we can get into the whole polarization argument that the reason why the surface matters is because its surface is going to break photons. It's going to scrape them into pieces, and you're just going to again put the pieces back in phase, which isn't that complicated again. All right, so he says the nth math calculations are presented here. Yes, well, we've already pointed to them. They're doing it from a different perspective, okay? Just like when they calculate the path length difference, they waste their time with this triangulation crap, and let's put the normal line through here and an angle here, and then we'll do sine theta times blah blah blah. When all you're really asking, the question you're asking is this line a full wavelength longer? So I'm just saying you could model it any way you want, right? I mean, you could just take the numbers and make a model on a board and just say, okay, I'm going to use L, the distance I'm going to use, whatever, 20 centimeters. Okay, and now I just come up with a proportional slit width to my 20 centimeters. If I say it's 20 centimeters and, it's really 5 meters, well, then I just do the appropriate change to the drawing. And I can make my slit, I can make my path lengths, and then I can just make a mechanical drawing, okay? And I can just mechanically do as Stephen Bro says he saw as a youngster or something, that I can just do the string thing, okay? I can just draw it. I can put a string here, okay? And then put a string here for my slits. And then I just figure out the proportional differences and make my string length a certain length, and then I can just do this. I can just have my string go on a nail and a pivot, and I can just move it across the field, and I can just mark it with wavelengths, so the string has wavelengths on it, and then I can just see where the lines hit, and then we're done. Because that's all that's in the math. The math is just a representation of these vectors. And the point is these vectors are going everywhere. They're going to every single location. So every location is getting hit by these vectors. And it's only at these locations where they're in phase. And that's where you see the light. All right, so the nth math, okay, is conceding the argument that I've been making that the surfaces are the sources. So there isn't one wave, in the single slit. So the single slit isn't the one wave experiment, it's two waves. And the two waves aren't here. Okay, that would be wrong. That's not going to get you the right answer. The two waves are right on the surface. The center of the waves are on the surface. That's their concession. They've conceded this already. So I mean, I shouldn't even have to make a very aggressive argument because they've already conceded this isn't the experiment they're claiming, because that's exactly what's happening in the double slit. So we just take the truth of the single slit. This is how they do it. There's no other way to do it. This is how they're doing it. And then when they get to the double slit, well, what are you doing? Well, you're just making, you're just making 4 of those little waves then. So it's just 2 single slit experiments. And the 2 single slit experiments aren't 1 and 2. The 2 single slit experiments are 1, okay, and 2. So that's the joke of it, the surfaces, okay? So the widest surface is one of the single slit experiments. That's giving you little bars, right? The wider it is, the smaller the bars. That's your little bars. And the single impediment, the shortest distance, that's giving you the big envelope. And there, yeah, that's all. This isn't that it's not that complicated, and this is so accurately true in terms of any kind of intuition or logic or any of that kind of stuff, and it's already built in. Like I said, their math is already conceding this point. So as soon as they say Huygens just means they do this. Huygens says that everything else got canceled, and all you have left are these 2 waves. Okay, so Huygens made an infinite number of waves, the infinite number of waves all canceled out except the first one and the last one. Yeah, they don't cancel. So that's what you're left with. But that's exactly what they're saying. So when they say Huygens, they're really saying we're conceding the argument that the action happens at the surface, right? The surface is where all the vectors are coming from. All right. So, I mean, they've already conceded it. That's the irony here. But they won't concede it in overt language. They won't just say, okay, I get it. It has nothing to do with this opening. The fringes are entirely created by the surfaces. That's the place where it's happening. And it's just, like I said, I don't want you to lose sight of that, because we're going to go into something more complicated. Like I said, I don't know how deep I'm going to go into it, because I think it can end up just being a distraction. All right, so I'll let that dry and read some more. All right, geometric end-slit calculations are presented here. Right, they're presented in the form, the way they're doing them. Just as I showed you math where you just do the simple thing. You say, how big is the opening? And now you're going to say, what's the difference between the line of the opening, the radius r, and the circumference I'm going to be putting it on? Well, that's pi. So I multiply it by pi. Okay, and then I just take the number I already know is in here, and I just put it on that bigger surface. So if I know there's 15 wavelengths between here and here, I know there's going to be 15 on that curved line. So I'm just really saying, what's the change in the size between the line of 15 wavelengths and the circumference I'm going to be putting them on, and that'll tell me how big each of the nodes are. And if I know how big they are, then I just obviously can just calculate where they're going to be. Now, the other key point they don't concede, right, that they don't understand, is the point I made about how the middle vectors are inside. They're the wrong diffraction. They're going in diffraction. They're going to a finite surface. And so all of that diffraction happens within less than a millimeter. So that doesn't mean anything. So the fact that the two lines are the same length in the center is an illusion, because the real pattern, okay, didn't start in the center. It starts at 90 degrees. At 90 degrees, the two lines are right on top of each other, and the wavelength difference, the length of your opening, is completely the distance of the change in the lines. And therefore, that's where the pattern starts. And if that's an off, then the pattern up here at 90 degrees is going to be different than when that's an on. They're going to end up in different locations. So that's a piece of the evidence that demonstrates, that they're missing something from their math. And so that's a mistake they make, is that their math says I just multiply n1, n2, n3 for the number of slits. But they're assuming the starting point, n1, is always an on, and it's not. So their numbers are actually off. If they actually did the experiment and calculated where their predictions are actually incorrect, but they never do that. They never test their predictions. They just say, we have the most predictive math in the history of mankind. It's the most perfect math ever invented. And they never test it against actual reality. They keep telling you it takes 4 times as much gas to go 60 miles an hour as 30 miles an hour, but you won't find an experiment proving it. That kind of bullshit. They say stuff, and they say it as if they proved it, but they never proved it. Alright, I was surprised that adding slits would not add more nested layers to the envelope. Okay, so this is the diffraction gradient. So it's just more slits, right? So it's, instead of, you have 1 slit, and then you can have 2, or you can have 3, or 5, or 10, or 500. And the real argument is, again, it's not the slits, it's the surfaces. So if you go test their, I can show it in the paper, but they're really just talking about surfaces. They're not talking about adding a slit. They're talking about adding a surface. You'd add a surface on both ends. So you add a surface here and here, and then you add a surface here and here. So when you're adding a slit, you're actually adding the widest distance surface. So you're just adding a surface with every addition of a slit. So that should be understood. And it's just the surfaces that again are accounting for the phenomena. And the further and further they're getting apart, the smaller and smaller they're getting. So in the past I described it this way. Let's say your envelope did turn out to be right in the center. Okay, so here's your big pattern. Well, if I have now I make the opening wider, so now I add a slit, which means I've increased the distance, the maximum distance between two surfaces. I've doubled it, right? And then I'm going to triple it, and then I'm going to quadruple. I'm going to keep doing that, and so I'm going to keep changing the size of the impediment, right? But they're going to line up. So this is going to be half the size of this one, and then the next one's going to be half the size of that. So if I keep n number just means this was n1, this is n2, this will be n3. And all it's really telling you is that's how many of these fit in there. And so I'm getting smaller and smaller and smaller. And the trick is, okay, is that even though these things will be they'll go out of alignment. Okay, so it looks they're all in perfect alignment here in the middle. There's actually a spot, okay, where because of resonant frequency, they're all harmonics of each other. So it'll get really ugly. They'll all be out of alignment. Like this will be on, and then this one will be. Let's see if I can draw it down here. So in a sense, if I go a little bit over, then there'll be another bar, and this bar won't be in the middle anymore. It'll be over here. And this one will be like over here, and this one will be over there, and so now they're going to start getting all unaligned. And then there's one spot, when you go far enough, all the harmonics line up again. They'll all look like this again. And so you're going to have a spot created in the center. And say if it was white light, that'll be white. And then if you use, full color, full spectrum light, well then you'll have your blue one first, and then your red, then your green, and then your blue. So the colors will separate over here. And but it'll be a spot, and it'll be actually an image of the laser beam. So whatever you put in, you'll get an image of. So in the center, you'll see the light. Like if it's a light bulb, you'll see the light bulb, an image of the light bulb. If you use a laser beam, you get a little round circle. If you use and then you'll get a little round circle over here. You get a round circle over here. You get an actual image will be cast. So when you use enough, if you use 500 lines per inch, 500 little slits, 1,000 little surfaces. Then you have a certain position where again they get all back in alignment again. So it's just really saying again that each source is sending photons, but they need to all be in phase from all the contributors for you to get the pieces to go back together again and create the entire image. So each image is really just, as I pointed out, a low resolution. That is, it's just made out of part of the light from, you're sending an image everywhere, so obviously you're diminishing the number of photons per the resolution of I'm just saying, so it's basically however many lines you have, it's just telling you how many lines you have in your image. Your image still has those lines in it. So it's like a TV image versus a HD image. It's like a 640 by 480 image versus a 1240 by 720 image, whatever. The resolution is just lower, but it's still there. The image information, the first slit information, second slit, that information is still in it. So that's why it comes out looking exactly like what you put in. Because you're just sending the images to all the locations. And there's only certain places where the image information is on top of each other, and therefore you can see it. But like I said, it gets a little more complicated to talk about that. But it's just geometry again, and there's just obviously it's predictable what the resident harmonics would be. They can figure out. You have two systems vibrating, and one of them's a little out of sync with the other, and then they'll go back into sync. So you can see that with air carts. You can put energy in, and they'll be bouncing all over the place, and then all of a sudden they'll go into sync, and they'll just do the same thing, but they're still a little tiny bit off, so they'll go out of sync again and get all wobbly, and then they'll go back into sync. So this is a common phenomenon They have math for it, but the math is, I'm just arguing, more complicated. Then you need to think about it in terms of, it's just when do I match the pattern, and that's it. It's just in phase, out of phase arguments, and they're just not any more complicated than that. So anyway, so yeah, so that link is okay, but it's, you know, who cares? Yeah, we've already conceded, we're already arguing that the secret math is that math. That's the math that works. So Lewin does the fake math first, you know, in his lectures, and then he gets to the, you know, the diffraction gradient and gives the right math. You know, and that's the way that they're playing a game. I don't know why they're playing the game. Well, the reason why they're playing the game is because if they use the math that works, it's clear that the surfaces are the source. That this isn't about the opening making a wave, it's about the surfaces making vectors. And that's why they use the fake math first, because it's still wavy. But the end math, yeah, they take all the wave guts out of it. Yeah, I can sort of show you that. That even in your own links, it's obvious. So let me go to, I think it's this one. There it is, plainly, right in front of your face. They draw it like the lines are coming out of the middle of the opening, right? So, I mean, maybe you can't see that, but it's just, you know, I've shown this before. I mean, this is a different version of exactly the same fraud, right? So they draw it in one case where, oh no, all these vectors are coming out of the middle of the opening as if it was a wave coming through the slit, you know, through the opening. Like the opening was the important feature. But then they do the little inset, and what does the inset show? No, it's about the surfaces. So they keep talking about how many openings, you know, how many slits are in the diffraction gradient, when all it's really about is how many surfaces are in the gradient. How many surfaces per inch is really deciding the pattern, because that's where your vectors are coming from. That's where the event takes place. And they're not arguing a mechanical surface theory, they're arguing a wave theory. So it's not going to look like a wave theory when you're drawing the lines right from the surfaces. And that's the whole point. That's the fraud of this. They really are committed to, you know, this overview picture of randomness and waves. And the fact is, their own math is conceding, no, that's not the answer. The fringes are created by light that goes through a surface, right? By a surface. And going by a surface means you went through the surface. If you go across a surface, you're really flying through. You've got to know there's atoms. The atoms are mostly empty space. You're really going through electrons and protons. What do you think a field of electron and protons are going to do except collect energy as you pass it through? The photons are going to hit them. They're going to give them momentum. They're going to move in some direction. The direction they move in is going to be the direction of the new photon, the new push into the universe. I've already, I've gone over some of this, and again, if the complexity isn't going to add any more insight, in my opinion. But you can see in their math, they have the signs, they have pi. So you're just really saying that their math is just conceding that this experiment is really about what happens at the surfaces. Alright, but you don't need this complex math to understand it, and you don't. All you need is the strings. Like I said, all you gotta do is put strings on the surfaces, do your L thing, and then just move it around, and you'll see where, in phase, out of phase, in phase, out of phase. And that the truest answer is always going to be at the 90 degrees. You can't assume, constructive interference forward. And the reason why the light bulb shows up in the diffraction gradient is because each one of those tiny little vectors going center are there, and they make an image. All right, but it doesn't mean that all the pattern is starting in the center. How to say that? Well, anyway, let's just leave it alone, because sometimes the more you say something, the more you just distract. So this was a question on Quora or someplace, yeah, Stack Exchange. So there was one answer. Somebody asked a weird question, right? When the double slit diffraction occurs, there are interference patterns inside, say the central diffraction maxima or envelope. I'm trying to understand how these interference fringes are created. Well, obviously they're created because it's a double slit. So, you know, I mean, and again, the obvious thing to understand is it's a multiple surface. Again, so you see a double slit, you see two openings, and what you're really missing is this inside. That's one of the slits thingies, and these two outside ones are the other. So instead of falling for it, it's two of these getting mixed. It's not two of these getting mixed. It's the inside dimension and the outside dimension that's getting mixed. That simple insight starts a roller coaster kind of, you know, that pushes it, that has you falling off a cliff. And there's no stopping. Once you recognize it's just stupid to think of it as these two. I have two single slits with the same dimensions, and that's what I'm combining. No, you're not. You're combining this single slit and the outside single slit. Those are the two. And once you see that, if I just told you that and you accepted it, so just that single fact, I put that on the table, you know, let me just draw it again just to be really clear. And all the puros, all the other buttholes out there who just keep saying it can't be that their bullshit wave theory isn't the truth. If you just concede that point, so I take two single slit experiments, right? I just take two, you know, this is the classical argument, is how, you know, so I take two single slit experiments, right? Okay, and you're saying all I'm going to do is move those two things closer. They do is something over here, and those two things don't combine because they're too far away. But now I bring them closer and closer together. The simple insight that I'm really not combining a wave coming out of here and a wave coming out of here. That's not what I'm combining. What I'm combining is this distance and this distance. That's what changes and makes them relevant to each other. This is one slit experiment, this big one, and this is another slit experiment, the little one in here. And once you have that insight, I don't see how you can still do your flying pig bullshit. The ground is coming right at you. The ground that says this isn't a wave theory. This is a surface theory. And it's a theory about breaking things and then remaking them. And I just don't know how you evade the ground. I mean, how do you understand that to be the truth? And then fit that into your silly wave nonsense, because it really just doesn't work. This wave, let's say if I could make waves here, okay, isn't interfering with this wave. Come on. Doesn't make any sense. You can't draw it that way. It doesn't work that way in water. It won't work. It's silly. It's nonsense. Come on. Come on. So, maybe I'll read the answer just because it is so, it's a bit, you know, it's short, and it's sort of saying exactly what I'm saying, but it's just saying it in such a cheaty kind of way. In the simplistic model, you can view destructive interference for the two slit situation as arising from one of two possible events. Either light from a single slit is destructively interfering, I don't even know what that means, hence the light from the other slit will as well, since the offset is usually ignored. So, sorry, this doesn't say anything. That's just, I don't know what that was. Or, okay, light leaving both slits interfere with each other. So again, it's not light leaving both slits, it's light interacting with the four surfaces. And the two inside ones are doing one set of things, and the two outside ones are doing something else. Okay, the smaller inner interference pattern is caused by interference between the slits. Is anybody saying that? Yes, of course it's being caused by the slits. Okay. The second option above, this is contrast to the diffraction envelope, which you stated is caused by interference of a single slit. So he keeps, how does that answer this question? Oh yeah, that's right, it doesn't. Okay, so let's see. For example, if light leaving the leftmost edge, so now there's the key word, right? For example, if light leaving the leftmost edge of the left slit, so now he's conceding the edge of the slit is where the wave is, right? So if you're going to have wave theory, you'd have to say, oh yeah, there's 4 waves, and they're right on the surfaces. So that's completely not what Young drew. It's not what anybody draws. It's not what Veritasium argues. Nobody's getting that. And yet, this physicist is arguing that's the way you have to think about it, or you can't explain it. And so he's saying it. Leftmost edge of the left slit. So he's saying the outside slit, right? Has a path length difference of lambda divided by 2 with respect to the corresponding edge of the right slit. So now he's just doubling the frequency, right? He's putting a 2 into the wavelength, which means he's cutting he's making the wavelength shorter, which is increasing the frequency of the light. So now you can get more wavelengths of light in the distance because he just cut it in half. So he just told you this edge is way over here, this edge is way over here. I need some way to make more, I need to represent that bigger distance. How do I represent the bigger distance? Well, I can do one of 2 things. I can admit how long the line is and then just divide the number of wavelengths into it. Or, right, I can make the wavelength smaller of the light and then say there's that many number inside of the old distance. And so he's just keeping the old distance and cutting the wavelength of the light in half with respect to this corresponding edge of the right slit. So he's just said left edge, right edge of the 2 outside dimensions, and he's conceding those are the things creating the little bars. So that's what's making the little jagged lines inside this picture, right? And this is such a silly representation of the actual pattern, right? Because we know the little lines are in the envelope. That means there's little lines here, and then there's little lines here. So they didn't even draw it right, which is, you know, pretty pitiful. I mean, the guy who asked the question has the crappy drawing, but, you know. Right slit then from those of the path will completely destructively interfere. So he's just choosing constructive versus destructive. It doesn't really matter. Furthermore, every point in one slit has a pair in the other slit that causes destructive interference. And he's just claiming that all of the stuff inside the slits is a bunch of destructive, and it really isn't. It's just not constructive. It's not going to remake a photon because it's out of phase. Of course it's out of phase. You'll notice that the first inner minimum occurs at the smallest angle than the single slit minimum. So, you know, he's basically, look, there's 2 slits. He's, you know, he didn't say that very precisely, but he's just saying, look, if you did these 2 outside surfaces, you still have to do the 2 inside surfaces. You know, this is consistent with d sine theta, you know, wavelength divided by 2, producing this smaller edge than the same since the slit separation is d. Okay, so I don't know where d isn't even, d sine theta equals the same thing as a divided by 2 sine theta. I don't even know what that means, but anyway. So the a is the width and d is the, that doesn't make any sense. Anyway, it doesn't, you get the point, right? He's already conceded it right here. If the light leaving the leftmost edge of the left slit, so there we go. So he's identifying the outer surfaces as the source of the little bars, which leaves you with the obvious conclusion that the source of the envelope are the 2 interior slits, the 2 interior surfaces. So it's a concession to the truth, and it certainly would make, if you drew it, it wouldn't look like a rational wave theory, and that's the point. And so it just makes this, I mean, what do you call that? I mean, what do you call the fact that he's conceding it? And he probably knows, well, that doesn't make any wave sense. Why would two waves be created out there? Two different waves. What water? That certainly won't happen in a water tank. The water tank doesn't have 4 waves in it. So, what can you call that? I mean, it's pretty dishonest, isn't it? I mean, pretty dishonest, isn't it? So anyway, all right, back to the comment. So I pretty much dealt with all of these links, but I'll just read some of this. All right, I found this was also asked at Stack Exchange. Does your model predict the same math-wise? Well, I'm just pointing out that obviously it's the same math, but I'm not doing sine thetas and all that crap because it's simpler than that. You don't have to do that. All you know is the circumference, because you know it's the circumference of a circle because you have a radius as your distance. So you know your distance is a radius. That means you're putting the whole pattern on a circumference. So all you have to do is multiply by pi to find out how big a line you're putting your 2 lines on, your vectors. Your vectors are made and they have to equal the radius, and you're placing the radius on the circumference. Okay, I know you had a bad experience with SE. They wish that people ask questions a certain way, plus it is purely appeal to authority site. Critical thinkers must hold their horses. I don't think holding your horses is a way to describe the absolute bigotry they have, and the whole idea that they make this obnoxious claim that none of these subjects are worth discussing. That's what they're really saying. It's not worth discussing how poorly evidenced and not completely coherent their theory is. That's not worth anyone's time. And that's bullshit. Neither of the above sources speaks about what it means for the wave-particle duality concept. Exactly. They don't concede that the 2-wave drawing is absolute horseshit. Young was not correct. There is no comparison between water wave or sound waves and what light is doing. They're not the same thing. They're not seems like. They're really nothing like. Because the patterns will be in completely different places than they will be in water. It's not the same mechanism. It's not anything physically similar. It's completely physically dissimilar. Okay. Are the fundamental structure and substance of a photon. So again, yes, they won't talk about how long a photon is. They won't talk about how high a photon is. They won't talk about how much stuff might be in a photon. None of those conversations they will have. It seems like other people have also explained the nested envelope pattern by purely using path length difference geometry. Right, well, I'm just saying the mathematical solution is one thing, okay? But obviously it doesn't, the math has to be connected to the geometry to be visible. So if you're using abstract connections, sine theta connections, well then you have to draw that geometry. And if you actually drew it, that's where they'd see where they're making their mistakes. And clearly it's a mistake to assume that the interior, the fact that there's a wavelength difference between the 2 lines inside of the slits, the diffraction going in is always constructive, doesn't mean the outside one is. It seems like other people have also explained the nested envelope pattern by purely using path length difference geometry. From one project well, they won't do it with 2 waves, so I'm just saying they'll never get the right answer using 2 vectors for the double slit experiment. That's not going to work. From one project last spring, I learned that scientists pick up the appropriate model for each situation. They don't have a model. They just have a formula. So let's understand. If they really modeled this stuff, again, you would see it. They would see the error of their ways. They would see that, okay, if I make 1 millimeter on the, on the target, what do I do with this thing? I mean, I know that the stuff going in can't possibly be diffracting, right? I mean, that's the logic here, right? The stuff going, anything going in, all right, has to be going to a smaller space, right? So if I want to say two lines are going in and they converge, I have to know that the space they're converging in has to be smaller than this space. They can't converge big. They have to converge smaller, right? They can't converge. They can't make a big spot over here by converging, okay? So that's called, this is diverging. This is converging. That they can't possibly converge into a big spot. So, you know, little things like that would become quite obvious if they drew any of this, okay? And they actually said, okay, well, what do I know is if this is 1 millimeter, this has to be 1 millimeter, and all this has to happen inside of 1 millimeter, so it's going to be pretty freaking irrelevant when I have a, you know, when I have a blob of light that's, you know, 10 centimeters across. That 1 millimeter is going to be pretty irrelevant. You could probably see that, right? Mostly. Yeah, you can see enough of that. Screw it. All right. Sometimes one is better than the other. So again, I just this bullshitting around what is quite obvious. Again, when somebody starts talking about the two outside surfaces, aren't they conceding the argument that one big wave isn't coming out of those two surfaces? So let's, why are we, I mean, the argument should be conceded. These people are all really dishonest because their math that works clearly isn't wave math. Clearly isn't. Could not predict the behavior of photons. That's what they say. So again, another one of the points that's just key is the Feynman argument that all these photons, it just doesn't matter whether the photon goes in near the surface or the photon goes directly through the middle. And you just know, that can't be true. Because you know when you have a single slit, a ton of the photons go straight through. You know that's what they're doing. That's why the center gets so insanely bright. Quantum electrodynamics seems to predict the envelope pattern, as we can read in this wiki article. So it's not there. Okay, I've read the wiki article. It's not on this wiki article, so they don't concede it. So you can say they do, but they don't. Now maybe you're thinking the envelope pattern has something to do with color separation, but it's not. It's a strictly very different concept. And in a diffraction gradient, it's kind of stupid to talk about the envelope pattern because it's an envelope pattern and an envelope pattern and an envelope pattern and an envelope pattern. It's a whole bunch of envelope patterns on top of each other. All of the patterns are just patterns. It only looks, we only make a distinction. In the double slit, we say envelope pattern because there's only two patterns. And we can clearly identify one as being small little stuff and one being big stuff. You know, but you can't pull that, you can't use that kind of rhetoric when you're talking about, you know, 500 patterns, right? You know, then it's kind of silly to say the envelope pattern. There's no envelope. They're just 500 distinctly different patterns that are progressively getting smaller and smaller and smaller and smaller and smaller, piled on top of each other. So this is going into some of the different ways you can create the simple truth is you can just use thread or wire. You know, you can use openings to create surfaces, or you can use diffraction gradients, which create the same idea as a surface by creating an inclined plane, which means you're creating different places where you're basically saying only one of these wavelengths will match the wavelength of the light from this one and will match the wavelength of the light from this one. So if you hit low on this one and in the middle on this one and at the top on this one, those will all be in phase, right? So the one that hits the top here, it will be in phase with the one in the middle here, will be in phase with the one at the end here, because now you're just, you're just shifting the distance. But I'm just, it's these arguments of the different geometry created by the different ways of doing the experiment. Like I said, it's just it's, you know, one could devote their entire life to their entire career to just understanding all of these subtleties. And so I don't, I don't think you're not seeing the forest through the trees kind of thing if you get too lost in that. But anyway, it's really not here any conversation about the two-slit experiment and envelopes. So, and again, diffraction gradients really aren't, you really can't call that, you can't identify an envelope because there really isn't one. The fact is that the biggest pattern will tell you where the image it will be. The biggest pattern, because the biggest pattern is the one that's obviously you have to match. It's the one that's just showing you most overtly where the match can possibly be, because you can say it can be possible in this range. I mean, if you have a big giant pattern, big lump here, big lump here, big lump here, that one's basically saying if I'm going to argue all of them have to line up, clearly that can only happen where the biggest envelope is. So the biggest envelope is basically just telling you where it's going to be in that range of that biggest envelope, and we know it's always going to be in the center of it. So it doesn't, so I'm just saying it does give you the answer. The biggest envelope is the only envelope you need to know where to predict where the pattern will be. The biggest, the smallest distance between surfaces will tell you where the range, and again, as long as you're doing a symmetrical experiment, the range will always be in the center of that biggest pattern. All right, so anyway, but it's nowhere in here. So if you want to show me where the envelope crap is in this page, I'd appreciate it, because after reading the whole page, I was a little pissed off that it wasn't in here. So certainly the word envelope isn't in here, right? I could do a search on the page and I'm not going to find the word envelope. So anyway, just my, subtle criticism. I'm just, I mean, you said quantum electrodynamics seems to predict. No, it doesn't really do that. Quantum electrodynamics is the silly theory of that, Feynman perverted it into. It's the silly theory that there's a random God, and this is a Heisenberg argument. The surfaces aren't causing anything. It's causing every single photon, okay, to be Heisenberged, because now I know a range of where it is, and now it's going to, diffract randomly, because I'm identifying its position. I mean, the logic is there, again, just understand, they don't understand that the photon has a size, and if I make the slit big enough, the photon can fit right through it and go straight. If the photon hits here, then it's going to get diffracted, because the edges is going to move stuff off of it. If it went in right here, it could just be a little tiny bit of it could go through the edge. So most of the photon is still in one piece, but there's one piece thrown off. I mean, it's just about breaking photons and then reconstructing them. Anyway. But the downside of QED is that it doesn't explain the physical dynamics of the experiment really, as well as geometric presentation does. So again, the fact that the lie of a wave theory looks better doesn't make it any better. So QED doesn't have a wave, it just has magic random God. Alright, and then the other crap is back to Young's silly, it's like water waves. That's not true. It's overtly wrong. There's not two waves that are creating the pattern in the double slit. So it's clearly bullshit. And there's clearly two waves in the single slit, which doesn't make any sense when you compare it to water. Yeah, anyway. The big question is, where do we really need QED? Oliver Costa wrote recently that there is something rotten in the history of the development of QED. Okay, so quantum electrodynamics. So this goes back to the 40 and all the infighting about models. And it's a good art. I mean, somebody wants to go. It's a good article for reading about all of the cheats that are built in, and some of them admitted by the people who are doing the cheating. Feynman, for example. Ours is not to wonder why. That's basically Feynman's philosophy. I don't care, okay, why it works. I just care that it works. That kind of bullshit. So I don't care how much I'm cheating the truth by creating metaphors for it. The angel theory can work, to explain some coincidences, different things. It'll work as a model, the angel theory. But come on, we know that it's not the truth. The angel theory. Anyway, so yeah, that's fine. This obviously doesn't mean anything to 99.9% of physicists don't care about any of that history. They don't care that they're rowing boats, that's dirty mob money that they're playing with, right? They know it's mobster money that's financing them in a sense, and they know that a lot of their physics is just bullshit, and they just don't care because it's got them a seat. It's working for them. It's not working for physics. It's working for them personally. Would be the better argument. And so why rock the boat that's working for them personally? And there's a lot of that in this physics. And obviously a few people got very powerful after the Manhattan Project. A lot of scientists, were gods. And those gods got to, decide everything about what the truth was going to be in physics. And a small number of people started making all the decisions. And you could say that was true in Newton's day, but Newton earned it. It's a huge difference, right? Newton earned the respect. He didn't steal it with one invention. He didn't come up with one idea and now he's king and he can opine on any subject. And Newton was such a good scientist that he didn't push it. He didn't try to explain more than he could. And so, anyway, it's no point in making these comparisons. I mean, the fact is we're stuck with human beings that really don't. They're just shitty trial lawyers. They don't care about. They don't know that they're there to protect the truth. They think they're there to get their client off the hook. I mean, they've lost focus. The truth doesn't matter. What's good for my crooked client and me, that's what matters. Alright. So, we'll call it a video and such. There's nothing. The internet is such a dead, shitty hole of crap. There's just nothing. I just don't believe how few intellectually engageable people there are on the internet. You can't even engage any intelligent minds to ponder a single question, to defend anything. It's just so bad. Yuck. Terrible. So, till the next time and such, I guess we'll just get the hell out of here. Yeah. So, this has been a DraftScience video presentation. Till the next time and such.